Hello everybody, it's Marlon Blanco. I'm going to be recording my video now for the part 2 of our exam. It's going to be in regards to our ICU project actually. For this project, we're not just building an app, we're building a lifeline pretty much. And in a standard commercial environment, a system crash is an inconvenience. In a hospital intensive care unit, a system crash is a casualty, perhaps. When we moved from consumer grade to mission critical, the entire project management philosophy kind of shifts. Today I'm going to be evaluating how this high-stakes environment fundamentally alters our strategy across 4 key pillars: risk, quality, cost, and scope. In a typical project, we might worry about market risk or schedule slippage. In an ICU, we worry about catastrophic technical risk, the risk being the signal silent failure. This occurs when the monitoring hardware appears to be functioning. The screen is on, the lights are green, but the underlying data stream has frozen or drifted. If a patient enters cardiac arrest during a silent failure, the system provides 0 alerts. The proactive response would be, instead of waiting for a crash to trigger a reboot, we implement failure mode and effects analysis at the start of the design phase. We would do hardware heartbeats, where we design a watchdog timer, a secondary independent circuit that requires a heartbeat signal from the software every 100 milliseconds, and predictive alerting. If the software fails to send that pulse, the hardware triggers a physical analog alarm that's independent of the digital OS. We don't just mitigate the risk of the crash, we mitigate the risk of undetected failure through physical redundancies. In many startups, the mantra is move fast and break things. But in medical tech, if you break things, people die, and this is why standard quality control is insufficient. The reason why QC fails here is QC is reactive. It's the inspecting the widgets at the end of the line approach in the ICU system. Finding a bug during the final test is a failure of the project management process itself, because it suggests the defect was allowed to live in the system for weeks. All right, and the QA process improvement, we sort of shift towards formal verification and validation. A specific QA improvement we've implemented is automated regression testing in a simulated environment. Every time a developer commits a single line of code, our QA pipeline authority runs that code against 5,000 hours of recorded medical edge cases, rare heart rhythms, power surges, and sensor disconnects. We're not just checking for bugs. We're building a process that makes bugs nearly impossible to introduce in the first place. Estimating the budget for ICU system is not just about counting developer hours, it's about factoring in hidden costs of the medical ecosystem. Regulatory compliance in the US, we must factor in the cost of FDA class certifications. This involves thousands of pages of documentation, traceability, matrices, and potentially hundreds of thousands of dollars in filing fees and legal audits. You're not just paying for the code, you're paying for the proof that the code is safe. The medical hardware can't use off-shelf consumer tablets. I mean, we need hardware with galvanic isolation to ensure a power surge in the monitor doesn't shock the patient through the electrodes. And biocompatible materials. The sensors must be non-toxic and withstand 24/7 sterilization with harsh chemicals. In a commercial app, scope creep, it usually means the project is late or over budget. In the ICU, scope creep is a safety hazard. I mean, the consequences of creep, imagine the marketing team wants to add social sharing or complex data visualization to the monitor. In a standard project, that's just a few more buttons. In the ICU, this leads to cognitive overload and alarm fatigue. If we add too many non-essential features, we clutter the UI. A nurse has roughly 2.5 seconds to glance at a monitor and access a patient stats. If scope creep has buried the oxygen saturation level under a new history graph feature, that delay can be pretty fatal. Our strategy would be to employ a zero-based scope policy. Every feature added must prove it reduces time to intervention. If a feature doesn't directly help save a life, it's considered a defect, not an upgrade. Managing an ICU monitoring project, I mean, it requires a shift from user delight to user safety. By prioritizing proactive risk mitigation, process-driven QA, regulatory-heavy budgeting, and a clinical lean scope, we ensure that our system doesn't just work, it protects. Thanks for listening, guys. Thank you for your time. If you have any more questions, please let me know. Have a good day, guys.